I've previously described how to use volley to retrieve a simple string from the web using the string request class. This project, volimages, picks up where the last one left off. In the main activity class, I added a definition of a string request and added callback methods in the anonymous inner types response.listener and response.errorListener. Now I'll show you how to do the same thing with images. So I'll do that work in the class flowerAdapter. In the current version of this class, I'm using an async task that I named ImageLoader. I'm also using a class called flowerInView that packages up references to everything I need to pass the information around to the async task. When you work with volley, a lot of this complexity goes away. Just as with the main activity, I won't need to define my own async task. I'll simply define the request, I'll define its callback methods, and I'll add it to a request queue. And volley will do everything else for me. About the only code I'm going to need from this async task is this line, where I'm defining the URL that I'm getting the image from. So I'll select and copy that line of code to the clipboard. Then I'll come back up here to the code where I'm making the request. And I'll get rid of all of this code where I'm packaging up the information and creating and executing my async task. I'll paste in that line of code that's creating the image URL. And now I'm ready for some volley code. First, I need to create my request queue. I'm going to declare the request queue as a field of the current class so that it persists for the lifetime of the class. This will allow me to add multiple requests to the queue, and volley will then manage the queue for me. I'll declare a private field, I'll set the data type as request queue, and I'll name it queue. Then I'll come down here to my constructor, and I'll instantiate the queue here. Just as in the main activity, I'll instantiate it with volley.newRequestQueue. Now, I'm passing in the current context to the flowerAdapter already, so I'm just taking that and passing it on to the queue, so that the queue is associated with the proper activity, the main activity in this case. So now I have a queue to manage my requests. The next step is to define the request. I'll come back down here to my getView method. I'll place the cursor after the line of code I'd moved, where I defined the image URL, and I'll declare an instance of an image request. This is another member of the com.android.volley.toolbox package. I'll name it request, and I'll instantiate it with the constructor method. And notice that this constructor has a few more arguments than the string request. The URL is pretty simple. That's the image URL that I just defined. Now, I'll make some extra space around some of these arguments to make it a little easier to read and to explain. I'll start with the listener. This is the anonymous inner type, the same kind of listener that I used with the string request, but instead of working with a string, it'll work with a bitmap. I'll implement the anonymous inner type with new response.listener. Notice that the generic declaration is set to bitmap. I'll use a quick fix and add unimplemented methods, and there's my response. The bitmap is passed in as arg0. I'll accept that name, that's fine. And within the onResponse method, I'm going to display the image. Now, I need to reorganize a little bit of other code to make this work. This is the code up here where I'm getting a reference to my image view. And right now it's inside a conditional block. I'm going to refactor this code. So I'm going to take this line of code where I'm getting a reference to the image view, and I'll cut and paste it so that it's outside the conditional block. And it'll be available even after I get into the else clause. In order to make this image reference available within this callback method, I need to make it final. That's because when I'm in the onResponse method, I'm in the inner class. And one of the rules of Java is that you can only refer to objects in the outer class if they're final. That is, they can't be modified. And now I can display the image. I'll go back to onResponse, and I'll call image.setImageBitmap, and I'll pass in arg0, the bitmap object. I'll also save the image to my cache. This is the LRU cache that I had implemented previously. So I'll call imageCache.put, and I'll pass in flower.getProductID as the key and arg0 as the value. I need to do a quick fix here, and just as with the image view, I need to change the declaration of the flower to final so that it's accessible from within this inner class. That was at line 57. So now I'm displaying the image and also saving it to cache so that I don't have to download it again later. That's the finished onResponse method. Now I'll go on to the other arguments. The max width and max height allow you to set the dimensions of the image you're retrieving, and it'll transform the images during the download process. This will save on memory and storage if you're working with images that start off larger but don't need to be that large when you display them. I'll set the max width and max height to 80 pixels each, and that will match the dimensions of my image view in my layout. Next, you need to pass in something called a bitmap config object, and there are some constants you can use for this. I'll use the expression bitmap.config, and I'll choose argb8888. This allocates plenty of memory per image. Take a look at the documentation for bitmap.config for more information on how this works. Next, I'll implement my error listener, and this is exactly like it was in the main activity. I'll use new response.errorListener. I'll use a quick fix to add unimplemented methods, and this is my error response. And all I'm going to do here is log it. I'll use the Android log class, and then I'll call the D method for debugging. I'll pass in a tag of flower adapter and the error message with arg0.getMessage. I'll clean up some of this code, moving the semicolon down one line, and now my request object has been defined. And finally, very importantly, don't forget this step, add the request to the queue. Now remember, when you're working with a list activity, the getView method that this code is inside will be called over and over and over again. So each time a new view is created or requested, this code will be called, and you'll be creating a new request and adding it to the queue. And it's up to Volley to manage the queue. There will be a lot of asynchronous tasks happening, but it's all being managed for you. And so now I don't need any of this other code. I'll remove the flower and view class declaration, and I'll remove the image loader class declaration. Those bits of code just aren't needed anymore. I'll organize my imports to make sure I've removed any unnecessary import declarations. Then I'll go back to my problems view and make sure I don't have any issues to clean up. And I'll run the app in the emulator. I'll click the action bar item, and notice how fast everything appears. And when I scroll down, notice that the images appear almost instantaneously. That's because there are multiple image requests happening simultaneously, all managed by the Volley library. Once you have this code working, you might want to check out some of the caching capabilities that are built into Volley. Volley has caching built in, but with images, you have to do some implementation of your own. So for the moment, I'm still using my caching strategy, using Android's LRU cache class to cache bitmaps in memory. But this is the power of the Volley library. I was able to remove all of the async task declarations in my app and replace all that code with a relatively small amount of code that uses callback methods to manage the responses. I also got the benefits of sizing the images and being able to configure their appearance. There's a lot more to learn about the Volley library. As I've mentioned previously, the documentation isn't very good at this point, but if you're used to working through Java API documentation and you're not adverse to looking at the source code, you'll see that there are a lot of great ideas that have been implemented in this library.